everyone. Welcome to the fifth and final virtual session of Project Teach. I'm just going to take some people off the screen for this first little bit while we welcome people in. I see that we already have some humans tuning in. We'll just give another minute or so to allow people to join. And maybe as you join, you can use the comment section on either Facebook or YouTube, wherever you're tuning in from, to let us know where you're calling in from, whose territory you're on. Maybe telling us a little bit about what drew you here even would be a really interesting piece of information. We won't spend too long in this lingering space or allowing people to arrive, as we do have a pretty jam-packed schedule today, but I'll give it another 30 seconds or so. I'm seeing the number is climbing slowly, so people are still starting to arrive. This is really where I find my stride, is just filling this dead air while we wait for people to join us.
We'll put some jokes in your script next time.
Yeah, we should. Yeah, I should have knock jokes while I welcome people to the space. All right. Well, I think that's sufficient time. We've got a little audience built up there. So if you're just joining us, please feel free to use the chat box to let us know where you're calling in from. But I'll turn things over to Nithya to get us started.
Thanks, Shauna. Hello, everyone, and welcome to Project Teach, talking about ecology and aims for conserving habitat. My name is Nithya Chari-Harris, and I'm a director of the Coexisting with Carnivores Alliance. I'm joined today by our panel of 3 experts, who I will introduce shortly, and by Shauna Dahl, Gulf Islands Forest Project Coordinator with Rain Coast Conservation Foundation. I will be facilitating today's discussion, and today's topic is an exciting one: recreation and conservation, the balancing act. We wish to express our gratitude and appreciation to be here on the unceded territories of the Sauk Nation and the neighboring Pacheedaht and Sianu nations, and the Songhees, Esquimalt, and the Wasiniich nations. But would also like to recognize the dozens of distinct Coast Salish and Nuu-chah-nulth nations, on whose territories most of us are in attendance today. Also, it is important at this time to give our gratitude and appreciation to the land, the waters, and the air, and all the diverse life within them that sustain our lives. I would like to invite everyone tuning in today to take a moment to remember whose land they're calling in from. We welcome you to make your own land acknowledgement in the chat box. Shauna?
So just a little bit of housekeeping before we get started. Those who joined us early have already heard me say this, but you can use the chat box to engage with our speakers today. That's the place where you can ask any questions that might come up during their talks. There'll be a little bit of time after each presenter's presentation to take 1 or maybe 2 questions before moving on to the next presenter. And if your question doesn't get addressed in that time, don't worry. There'll be time to address those at the end when we all come back together for more of a panel discussion. So with that, we'll turn things over to our first presenter.
Great. Okay, our first presenter is Dr. Cole Burton, who's a conservation biologist and wildlife ecologist with broad interest in using science to inform biodiversity conservation, environmental management, and human-wildlife coexistence. His recent work has focused primarily on the ecology, management, and monitoring of terrestrial mammal communities in the transforming landscapes of Western Canada. In 2017, he's Wildlife Coexistence Lab, WildCo, at UBC, where he's a Canada Research Chair in Terrestrial Mammal Conservation and an Associate Professor in the Department of Forest Resources Management. Welcome, Cole.
Great. Thank you very much, Nithya. I hope everyone can hear me all right. Thanks to Nithya and Shauna and the other organizers for the opportunity to speak today and to be part of this session. I'm joining you today from the traditional territory of the Wasanich people, just outside of Victoria, BC. And I'm excited to be able to talk to you along with Sarah and Gabe on this topic of conservation and recreation. So I'm going to speak a little bit about some of the work that my lab has been doing over the last couple of years on this topic, particularly focused on potential effects of recreation on wildlife, or more specifically on terrestrial mammals. So let's see if I can advance my slides here. Great. I hope you now see the second slide. And when we think about conservation and recreation, we might think about a potential win-win scenario. We know we have a tremendous system of parks and protected areas in British Columbia, and these parks and natural areas protect really important habitats for the conservation of biodiversity, including conservation of sensitive species like this mountain goat here that we camera trapped in Cathedral Park. And at the same time, these parks and natural spaces provide tremendous opportunities for people. They provide inspiration to get outdoors and to create advocates for the protection of wild spaces as people connect emotionally with these landscapes, but also they create economic benefits of protecting these areas and provide other important benefits to people, cultural benefits, health benefits, things like that. So really, we do have a great potential for this kind of win-win scenario. But we might also envision or worry about a different type of scenario, one tainted perhaps with overcrowding of parks as visitation levels grow to the point where wildlife might be negatively impacted. So on the left here, there's a photo of Joffre Lakes Provincial Park in BC, which has become a bit of an Instagram poster child as people access the beautiful glacial lakes for photos and recreation opportunities. And Joffre Lakes has grown in visitation by over 200% in the recent decade to over 200,000 visitors a year now. And on the right, we see kind of a more extreme case is a photo from Yellowstone National Park, one of the most visited parks in North America, which receives almost 5 million visitors a year. And we can see an example of a bear jam and a potential type of impact on wildlife of these increasing visitor levels. And of course, we know that, or we imagine that increasing recreation can have impacts on wildlife. But particularly here in BC and in many other areas, we don't or haven't really had a lot of capacity to monitor wildlife and visitor use in parks. So it's important that we think about, as this visitor use grows, how wildlife might be affected. And of course, it's possible that recreation and wildlife are compatible and that we don't really see effects as both are able to use parks and wild spaces. Or we might even see attraction by wildlife to people in these areas as wildlife might seek perceived benefits such as food resources. But if wildlife perceive risks from people, which ecological theory and evidence suggests they might, then we might expect wildlife will be displaced as recreation levels increase. So they might lose access to certain habitats and be forced out of certain parts of parks or natural spaces. But where wildlife don't have an option to move or want to use resources that recreators are also using, we might see temporal displacement. So we might see wildlife changing their time of use, such as becoming more nocturnal to avoid recreation activities that take place primarily during the day. And of course, we don't expect a simple, consistent or uniform response across different species. We might expect different species to respond in different ways. Some might be attracted to people for food subsidies or other things. Others might be more sensitive and might in fact drop out of areas that have high levels of recreation. And similarly, we might expect different responses to different types of recreation. So for example, we also often think about motorized recreation as potentially having stronger impacts to wildlife than non-motorized. But we really need a way to test these ideas in the parks that we care about and that we want to achieve this balance in. And so in our lab, we've been working a lot with camera traps or trail cams, which we think are a great tool for trying to simultaneously monitor both wildlife and people. So if you don't blink while you're watching this little time lapse of some of our camera trap photos from Cathedral Park, you'll see that in this case, lots of people using this trail, but wildlife are also sharing this trail with them. So wildlife are moving through, in some cases, predators like cougars, just minutes apart from recreators. So we think this is a great tool if we can deploy it in different areas to try and understand these relationships between hikers and people. And so we've been doing that over the past few years in our lab in a partnership with BC Parks, where we've deployed over 200 camera traps in 5 different parks in southwestern BC, ranging from Golden Ears Park here on the doorstep of Vancouver, out to Cathedral Park, which I mentioned out near Carameus, and up to South Chilcotin's Mountain Park up northwest of Lillooet, as well as Joffrey Lakes and Garibaldi. I'm going to focus today on a little snapshot of some results from South Chilcotin's, Golden Ears, and Cathedral, just to give you a little glimpse into the kinds of things we're learning in some of our research. So jumping right into Golden Ears Park, this is, I'm sure many of you know, a park around Maple Ridge, so just on the edge of Metro Vancouver. It receives really high levels of visitation, about 1 million visitors per year, with the busiest campground in the province. And starting in 2019, we set up 58 camera traps in the park, and this was a project led by Michael Procco, who just recently completed his master's thesis on this. And we set cameras both on and off trails, ranging from up in the front country of the park to well into the back country, and also extending out into the adjacent Malcolm Knapp Research Forest. And these cameras detected a range of mammal species, 19 in total, including some rare species like this spotted skunk. And Michael put together a fantastic story map of some of the results, so I encourage you to check that out because I'm just going to be breezing through this today. But Michael also did a lot of heavy lifting statistical modeling to try and understand this relationship between recreation activity and wildlife. So I can't really do justice to all the statistics here in a snapshot, but I'll try and show you some of it. And I will refer you to the paper that Michael led that was just published this week, so you can get all the details in there if you like. But just quickly, this graph that I'm showing here is an estimate of the effect of different variables on wildlife habitat use. So how often we detected wildlife in each week that we were sampling. We focused on the relationship between this habitat use and recreation activity, but we also controlled for other variables. And despite the fact that many species, particularly predators, used trails. So I should explain here, this estimate along this line means no effect of the variable on wildlife, whereas on this side it means a negative effect, and on this side it means a positive effect. So we saw that many species that we detected and focused the modeling on, particularly predator species, used the trails in the park. They were associated with the trails, which is these bands on the positive side. But we did see some negative associations with the level of human activity on those trails. But really only for hiking, we saw a negative association with bobcats, which is indicated down here. We did see a negative association for black bears and vehicle use in the research forest primarily. But for the other species, we didn't detect these strong effects of recreation at this weekly scale. But for cougars, we did see another interesting pattern in this work, where when the entire park was closed for about a month at the beginning of the COVID-19 pandemic during the first wave of lockdowns, the park transitioned from a lot of activity to no activity and back to recreation activity again. And what we saw, which you can see in the blue line in this graph, is an increase in cougar detections during that closed period. So they went from few detections to being detected more often in the park to few detections after the park opened up again, whereas we didn't see that pattern in other species like black-tailed deer. So we did see evidence for these 3 species of some negative associations with human activity in the park. Jumping quickly now over to another park, South Chilcotin Mountains up northwest of Lillooet. This is where we've been sampling cameras for several years, thanks to the hard work and great efforts of Robin Naidu, my colleague who works at WWF. And in this case, obviously it's much further from the big city and gets much less activity and land use disturbance around it, but it has become known as a destination for mountain biking. So it's seen high levels of mountain bike activity in the park over recent years. And Robin led setting out cameras across much of the park as well as areas outside of the park, and has been leading some statistical analysis again on this relationship between recreation activity and wildlife. So I should say too, we've detected more species in this park than we did in golden ears, 26 mammal species. And again, I don't have time to go into all the details of the analysis we've done so far, but this is also published in a paper from almost 2 years ago now that you can find some more details in. But one interesting result I'll highlight here is we did find evidence across all species of some displacement of wildlife using trails, displacement by recreation activity. So we used something called an avoidance attraction ratio, where we measured the time before a recreation event to the previous wildlife detection relative to the time after that recreation event to see if there was a lag after a recreation activity or event was detected. Was there a lag indicating that wildlife were displaced a bit more after that event? And if there was no lag, if there was no evidence of displacement, our estimates from our models would be at this level of 0. But you can see they were all positive, they were all above 0. So for different types of recreation activities, there was some evidence that wildlife avoided the trail after that recreation activity. And the evidence was strongest or pretty much strongest for mountain biking activity. So this is mountain biking here, very similar to the response we saw for motorized recreation activity and higher than we saw for hiking and horseback riding. So that was one of the results from this area. And then my last little quick stop at some of our results is in Cathedral Park out near Caramios, where Mitch Fennell has been running our camera trap grid for the last couple of years. Mitch is just finishing up his master's now. And Cathedral is a park that sees a lot of hiking activity, but doesn't have the mountain biking of South Chilcotins and doesn't have the it's not near the city like Golden Ears, so has much less activity. And we did detect the most number of mammal species in this park, 29 different species. Mitch also did some statistical modeling like in the other parks. And here I'm just showing a graph that he prepared, focusing in on this estimated effect of recreation. So how was the wildlife habitat use related to the human activity in the park? And again, an estimate of 0 would be an indication of no effect. And these are the confidence intervals. So if they're overlapping 0, that suggests no effect. And on the negative side, we only detected a negative association with recreation for coyotes, which was interesting because we didn't see that for coyotes in the other parks. But we did see these interesting, strongest positive associations with recreations for mountain goat and mule deer, which may be a response by these prey species to the fact that several of the predators had sort of a negative trend towards recreation. But for mountain goats, we also know in this park they're actually attracted to campgrounds for the urine that people live there as a source of salt for mountain goats, which are often in salt deficiency. So this effect may extend to the hiking trails where goats are actually attracted to places where people are. But an interesting result here is that even though mountain goats are sharing space with people, with hiking activity, we've seen an indication that they're avoiding people in time. So Mitch split up an estimate of mountain goat activity between our off-trail cameras and our on-trail cameras. And this is just the time of day in these graphs. And the red line is mountain goat activity. The black line is human activity. So humans are only detected really on trails, but we've put the curve on both of these just for comparison. And you can see off-trail mountain goats were active throughout the day, a fairly flat line here, lots of activity in the middle of the day. Whereas on the trails where people were, mountain goats seemed to really change their time of use. So they were most active early in the morning before people were, and then dropped off rapidly once people got on the trails. So this seems to be a strategy for mountain goats to reduce the risk of encounters with people while still capitalizing on some of these resources that people provide. So I think I'm out of time here, so I just wanted to put some summaries on here, and apologies for the text. But we're getting some interesting insights from this, and sometimes it's hard to know whether to be sort of worried or encouraged by what we see. But I think it's important to keep perspective that we are detecting these diverse mammal communities in these parks that are supporting a lot of recreation activity. So that's great. Parks are very important in protecting habitat. We need to keep that in mind. But we are seeing some negative associations for certain species with recreation activity. A lot of variability in species responses, including the same species in different parks, but some general trends that predators may be more sensitive to recreation activity, which makes sense in terms of the risk of encounters and consequences for predators if they encounter people. And some activities, potentially what we saw in the Chilcotins, mountain biking may be having more impact. So I think there's a lot of work left to do. We need to know what are the consequences of these behavioral responses. We're only measuring these behavioral responses of animals, but we need to know if these are actually adaptations that promote coexistence, or these infer costs to the animals that will affect their populations more broadly. And we also need to think about what happens when recreation levels continue to grow and interact with other things like land use disturbances or habitat changes and climate change. So we suggest that there's a real need for long-term monitoring of this sort, and to be thinking about proactive management before the problems really get worse. So I'll end there, and thank you very much for listening.
Thanks, Cole. That's fantastic. You know, we have an intuitive feeling that the wildlife is affected by all the recreation, but it's great to see the quantitative data on this. We have one question for you right now. So in this region, CRD Parks is presently embarking on a park strategic plan. So we know that a large portion of parks are a refuge for wildlife, including the big predators. And with this information that you have, what advice can you give them with regards to ensuring that this wildlife refuge continues to exist when recreation use is growing immensely in this region?
Right. Yeah. Well, it's a great question and a challenging one, but I think briefly, I think it is important to monitor these changes as we're opening up new areas or anticipating changes in recreation levels or types. I really do think it's important to monitor that so we can get some good evidence, because these decisions around opening areas or excluding people from areas can be quite controversial. So it's really important to have some good monitoring data to understand what kind of changes we're seeing. And I also think, based on the evidence that we have from other areas, we need to be thinking about spatial refuges for animals. So even if a park is getting more recreation activity, we need to think about areas with good habitats that don't get some of that activity, so that animals can have a place to go if they are avoiding some of the increases in recreation. And we might also need to think about temporal refuges, in the sense of not allowing off-hour recreation or things like that that might impact animals that are changing their time of activity to avoid recreation. So thinking proactively about putting in some of those, but also really measuring these potential trade-offs and trying to understand if our management is working the way we intend it to, I think, are critical.
Sounds pretty good. Sounds like some good proactive management ideas. I think we have more questions, Cole, but we'll wait till we have all the other presenters. So I think we'll move on to our second presenter now. Okay, so our next presenter is Dr. Sarah Militi. And Sarah's career is focused on taking a holistic view to wildlife and landscape planning, both in and out of protected areas. Her master's and PhD integrated biological and social research to understand how bears and recreationalists share some of Western Canada's most prominent parks and protected areas. As a professional conservationist, Sarah has worked with teams of people to create new provincial parks, increase species protection, and design facility plans that serve wildlife and people. Sarah has also worked with various First Nations to improve her own holistic understanding of ecosystems and to explore ways that Indigenous knowledge can be woven into Western science to influence land and wildlife management. Sarah's first full-length book, What Bears Teach Us, was published in 2020. Welcome, Sarah.
Thanks so much for having me. It's a pleasure to be here today. Thanks, Nitya. I'm just going to share my screen here. Okay. And you should be looking at my title slide now. So
Yes.
I'll just jump right in. Thank you so much for inviting me to be a part of Project Teach webinar series today. I just want to acknowledge and appreciate that I'm coming to you from Canmore, Alberta, which is on the traditional lands of the Treaty 7 First Nations. And I acknowledge and thank the many stewards of the land that came before me and enable me to live, work, and play where and how I do. In the past couple of years, we've all seen a pretty dramatic rise in outdoor recreation, both in and outside of protected areas. And it's not just the volume of recreation that I think is important, as Cole kind of pointed out in some of his slides. It's how people are recreating and when they're recreating, and as well as the volume of people on the landscape. So really, when we think about outdoor recreation and the impacts on wildlife, I think we can think about multiple temporal and spatial scales, and you'll see some of that in my presentation. Before I get too far into this, I always come back to this quote from one of my profs during my master's degree, which was really that grizzly bear or wildlife management is really just as much people management. And especially when it comes to recreation, we often have more success when we manage people. For example, it's a lot easier to tell a person where or when or how they can or cannot recreate than it is to tell a bear not to eat in this particular berry patch or not to walk through this wildlife corridor. I just wanted to throw a slide up about a little bit of my background. I'm going to be talking today about my research in the Canadian Rocky Mountain National Parks, but all of this journey did start for me on the coast, and I know you're mostly coastal folks who are tuned in. So my master's work was in the Coutts-Matine, looking at the impacts of bear viewing on grizzly bear behavior just north of Prince Rupert. I took a similar approach in my PhD in that I wanted to understand the impacts of tourism on bear behavior. But for all of my research, I've always integrated a social science component because I think it's important to know what people think also. So when a bear and a person encounter each other on a trail, a lot of things are happening, both for the person and for the bear. My overall research goal was to try to understand that dynamic and then try to understand if it's a big deal or if it's not really a big deal for the person or the bear. So, you know, the bear is running into the person, and the bear could be thinking about its relationship to conspecifics on the landscape, food availability in the area, its previous encounters with people, and all kinds of things like that. And the person runs into the bear, and the person could be thinking about their level of preparedness, like how ready are they to see a bear, how many bears they've encountered in the past and what those experiences are like, and their bear-related knowledge. And how the person and the bear react in this scenario is based on all of this past experience and past knowledge. So both people and bears learn. And we often, when we talk about encounters, we talk a lot about trying to understand what the bear is going to do next. But my point is that you might not be able to predict the bear's response because the bear is an individual with a lot of previous experience too. You can definitely predict your response because, well, you're in your own head, obviously. So the overall research goal of my thesis was to really integrate the biological and the social science data to define management tactics that maximized grizzly bear habitat security while simultaneously meeting trail user expectations of bear management in Canada's Rocky Mountain National Parks. I chose an integrated approach because even though research can be focused on how wildlife change their habitat use or behavior around people, the management actions are usually focused on people. And so therefore, it's just as important to understand what people want to happen as it is to understand what bears need. So my research aimed to incorporate a social element with traditional grizzly bear habitat use models to create holistic management recommendations. So my three main research objectives were to look at what are the spatial and temporal relationships between grizzly bears and people on trails, to define potential thresholds of human use that might affect grizzly bear trail use, and then to look at trail user support for various management options when bears are in the area. My study area was the Canadian Rocky Mountain National Park, so Banff, Jasper, Kootenay, and Yoho. This area is home to approximately 200 grizzly bears and is visited by over 5 million tourists annually. I think that that number has probably jumped to 6 million since the pandemic, but I haven't calculated it. And it's a landscape with highly varied levels of anthropogenic impact. So obviously the towns of Banff and Jasper and Lake Louise are towns. That's, you know, a real high level of anthropogenic impact, but there's also some really deep backcountry in these national parks with very little human use and very little human activity. So I conducted this research using 3 main data sets. I had remote cameras, and they were deployed on randomly selected trails from May 1st to October 15th. And in total, I had 192 cameras on 34 trail networks in Banff, Kootenay, and Yoho National Parks, for a total of just over 3,300 camera trap nights, which is like a 24-hour period with a camera. I also had GPS collar data that I obtained from Parks Canada. At the time, Parks Canada had 27 grizzly bears with collars, and that was part of a habitat study that they were working on with CP Rail. So looking at grizzly bear habitat use around the highway and the railway, and I just was fortunate enough to be able to use that data. And then I also did a trail user survey disseminated at randomly selected trailheads in the morning, and I was assessing hiker preparedness and support for management options. In total, I ended up with 696 completed surveys and a response rate of 63%. And I just want to take a minute here to thank the 97 volunteers who worked on this project with me. They worked on putting up and taking down remote cameras and data entry, and also keeping me a little bit sane and giving me lots of people to enjoy the wilderness with. I could not have done this project without this, like, almost 100 people helping me out. So what did we learn? Well, from the remote cameras, the thing that's the most obvious almost instantly is that there's a lot of people and very few bears in this landscape. So I had separated trails into low, medium, and high human use. And regardless of the trail level of human use, there's a lot more people than bears on the trail. So we had just under 150,000 images of people entered into analysis, and 53 pictures of grizzly bears entered into analysis. So from the remote camera data, I did a presence absence analysis, and I showed that, and that data showed that grizzly bears were significantly more likely to be detected on trails during the spring than during the summer and the fall. Bears consistently selected for high quality habitat, although most of the significance for that came out of the GPS collars, not the cameras. That's okay, we'll get there. But the remote camera data also showed that grizzly bears selected trails closer to roads in the spring and versus the other seasons. And that to me was a little bit surprising, but I think is likely an artifact of the fact of the late melting snowpack that actually funnels everybody, people and bears, into the valley bottoms. And so during the spring, grizzly bears will select habitat closer to trails and closer to roads, partly because those are the first areas to green up because they happen to be open canopy and dandelions and that sort of thing. And then in the summer and the fall, everybody kind of has a little bit more landscape to play with. And so habitat selection changes a little bit. Bears have more options. Interestingly, the trail's human use level was not a significant predictor of grizzly bear trail use. And that kind of surprised me, but I did find, similar to what Cole was saying with the mountain goats, I did a breakpoint regression analysis, and I showed that most of the remote camera detections of bears occurred either at night or before 8 human events on the trail. So bears are choosing to use these trails either at night or early in the morning before they get too busy, basically. And 8 human events is like, that's not even a very busy trail. So that really is happening like before 6 a.m. most of the time. One of the most obvious results from the remote cameras was that people were active on trails in the study area throughout the days, weeks, and seasons. People were active on trails as early as 4:30 a.m. and as late as 12:30 a.m. So there's actually a very small window of time in these national parks where people are not active, and that creates an interesting dynamic for bears that are maybe a little more wary of human use. And then I also looked at human use and found that human use levels are highest on shorter trails, closer to town, and on the weekends. So I did what's called a step selection function, and I've got 3 graphs here. I just want to point out that if these numbers are positive, that means that increasing distance equals increased use. And if they're negative, that means that decreasing distance is increased use. So these bears are selecting habitats at greater distances from low use trails, and these bears are selecting habitats closer to low use trails. The X's are a significant relationship. And so this data is coming from the GPS collars. I did what's called a step selection function, which is just looking at how bears move through the landscape. And I included the low, medium, and high human use trails as a covariate in this analysis. Although I wanted to average each of those X's or diamonds as an individual bear, and I did want to average across age sex classes, but you can see that there's a lot of variation. And, if we look here, for example, distance to high use trails, well, 2 females with cubs actually select habitat far away from high use trails, and 2 females with cubs select habitat close to high use trails. So if I was going to average across females with cubs, I would have come out with a result that isn't really reflective of how these individual females with cubs use the landscape. I did find that most bears, except 1 adult male, consistently selected for high quality habitat. But the relationship with all other covariates was really higher levels of individual variation. Half of the bears selected habitat close to roads in the study, whereas others avoided them. And most grizzly bears selected for habitat closer to low human use trails. But as you can see, some of them selected habitat farther from low use trails. With a general linear mixed model, I examined grizzly bear step lengths. So that's like the distance the grizzly bear moved in 2 hours between GPS locations. And I found that step lengths were longer during the day, suggesting that grizzly bears in this area are still diurnally active. And step lengths were shorter, however, during the day when in proximity to low use trails, suggesting that when bears are using habitat close to low use trails, they're not moving around as much. So they could be foraging or resting or whatever. The trail user survey found that most users were open to restrictive management style options and were supportive of actions that prioritize grizzly bear habitat use over their own recreational needs. So in this figure here, we've got green, yellow, red. So green is supported by most trail users. And these actions were ones that targeted the trail properties or human use, such as closing the trail or having group sizes of 4 or more, prohibiting dogs, that kind of thing, supported overall. Requiring people to book in advance or instilling a maximum number of people per day had more neutral levels of support. Those are not management actions that are currently applied in the national parks. And I think it's kind of like people just have never heard of that before. And then management actions specifically targeting the bear, such as aversive conditioning or relocation, were opposed. The level of support for various management options was different if it was a lone bear or a female with cubs in the area. So restrictive management options like closing the trail or not allowing dogs or group sizes of more than 4, those things are more supported if it was a female with cubs in the area. Whereas not taking any management action or applying aversive conditioning were more supported if it was a lone grizzly bear. So people do expect a different management response if it's a lone grizzly bear or a female with cubs in the area. And I'll just also throw in a plug for my recent publication. This work The survey was recently published in 2021 in the Journal of Outdoor Recreation and Tourism, and that is open access as well. So when I look at the final recommendations, we've got the things that the visitors support or oppose, and we know that bears are active during the day and they're on trails in the spring, and they're individually selecting habitat based on their own personal experience. And so some of the main management recommendations I came up with were to try implementing trail opening times on trails in high quality habitat, particularly during the spring, so we could give bears more space when they need it. Closing the trail when a female with cubs is in proximity to trails and accessing high quality habitat. That's good for the female with cubs, and people expect that management action to happen. And I also think that it's a good idea to have public education programs to explain why aversive conditioning is done and how it benefits bears and people. And with that, I will close it off. Thank you so much for your time today, and just thanks to all my supporters who made this research possible. And thanks again.
That's great, Sarah. Thank you so much. That's so interesting, and I'm looking forward to reading your book. So one question that we have here for you. So from your experience, and in your last slide talked about education for the trail users, what are the most effective options for providing education that in an area where bears and other big carnivores also use that are also used by big carnivores on the trails?
Yeah, Nitya, it's really funny that you should ask that question today, because in my other job, I'm the executive director of the Alberta chapter of the Wildlife Society, and I just hosted a webinar yesterday about recreation and wildlife. And one of those presentations was on the effectiveness of different education and communication tools. And her work, her name's CJ Bly, she's from the University of Alberta, but her research really clearly showed that the most effective form of communication and education is direct interpretation. So that's a person on site talking to people, delivering programs. But closely behind is like signage and more passive forms of communication. I think when it comes to large carnivores and coexistence, people are getting their information from a lot of different outlets and sources. And I think our job as scientists is almost to try to counterbalance the perception that is most prolific in the media, which is that grizzly bears want to kill you and eat you. And so I think we really have our work cut out for us in terms of talking about the individual personalities of bears, and also talking about how our behavior is part of the bear's behavior. Like, we're in a relationship with carnivores, and what we do is also part of that relationship. So sometimes we as people like to remove ourselves from the equation, and it's like, oh, bears are violent or cougars are predatory or whatever, but we're having a relationship with these animals, whether we see it or not. And so I think part of our responsibility as biologists is to help communicate that, so that people kind of see it a little differently.
That sounds like a good start. I think we need to have a longer conversation about this. Thank you so much, Sarah.
Thanks for having me.
We'll have more questions for you at the end of the session. Okay, we'll go on to our third presenter. And our third presenter is Gabe Shepas, who's an early career ecologist with an interest in analytical statistics and modeling to support conservation and stewardship. A recent internship at Yellowstone to Yukon Conservation Initiative worked to develop tools to inform cross-boundary wildlife management in the face of various threats. As part of the project on recreation ecology, Gabe developed predictive habitat maps Wolverines. His other work includes landscape level analysis of ecological change, such as vegetation shifts in the Rockies. We're currently working on multi-species conservation modeling of critical habitat in interior BC. Welcome, Gabe.
Thank you, Nithya. I hope everyone can hear me all right. Hello, as Nithya said, my name is Gabe Shepas. Today, I'm joining you from the unceded lands of the Lekwungen people, known today as the Songhees and Esquimalt First Nations. As an early career ecologist, I'm excited to be here to share and learn from this webinar. And today I'll be speaking a bit about what I've been working on with the Yellowstone to Yukon Conservation Initiative, where we're looking at human and wolverine habitat use hotspots. So this is us. We're both ecologists and avid recreationalists. So this project is both near and dear to our hearts. So Y2Y is an environmental NGO that spans across 2 countries and the homelands of over 75 Indigenous groups. And a big focus of Y2Y's work is on the interface of people and nature. So when we think about these landscapes, they're very productive landscapes. They provide water, forest, natural resource, and agriculture, among other industries. And they're also hugely popular for recreation. So our project at Y2Y on recreation ecology is based on the study of environmental impacts of these recreational activities. But the field itself is usually focused on small scale, site-specific or at a single park or a single species studies, which makes it difficult to extrapolate that to a landscape-wide management plan. So what we are trying to do with this project is look at a larger scale and this more multifaceted social science integrated wildlife and human aspect of these recreation conflicts. So this is a great time to be doing this study because recent technology advancements have brought a lot of data on provided to us by recreation users using things such as GPS watches to log their activities. Here's our team. We've got many scientists and partners. We're lucky, and we couldn't do this work without all of our governmental and conservation partners, because this work really is spans many borders and many management areas. So for this recreation study, we are looking at the Upper Columbia watershed and the Kananaskis Ghost area, which straddle the Rocky Mountains and Banff National Park. So when we think about a large study area, the one that we've selected here is over 60,000 kilometers square. It includes both federal and provincially managed lands. And these landscapes along Highway 1 especially are increasingly busy, both inside and outside of parks. And outside of parks, there are very little to no management plans on recreation. So for this project, we're working to use data that already exists to create an evidence-based synthesis. So we can pull models and data together to inform predictions on land use for different groups. So data on recreationalists includes things like trail counters, surveys, interviews, and online activity logs such as Strava. We can gather information from users about the location, time, and intensity of recreation. There's also a ton of wildlife data that already exists for the study area. Researchers and managers have gathered data on animal occurrences and movements, which are used to create habitat suitability models. And these models are essentially used to identify the best habitat and are especially important for species at risk such as grizzly bear, wolverine, mountain caribou, and trout. While both human and wildlife data are essential to this recreation ecology project, I'm going to dive deeper today on the piece that I've been working on, which is the wildlife data. So we chose Wolverine as the first species to synthesize habitat data for. Wolverine are long-ranging, cryptic, and especially sensitive to recreation impacts in the Rockies. The main reason we're interested in habitat suitability predictions is to identify human and wildlife hotspots. As part of the recreation ecology project, we're interested in knowing where these areas might overlap. For example, where wolverines might build dens on backcountry ski slopes. We can then share maps and data with conservation partners, which could help inform management decisions such as habitat closures. Conservation partners such as parks and communities have expressed interest in these habitat suitability maps, as this kind of spatial data doesn't exist in our study area yet. When we talk about wildlife modeling, it's important to remember that models are a tool to understand and simplify complex systems. So these habitat suitability maps provide predictions of the quality of an animal's habitat based on its use, and they're based on data from GPS collars and DNA hair snagging stations. And we model where wildlife are and aren't based on these landscape features, such as forest type, food resources, climate, terrain, and anthropogenic development. To synthesize the existing habitat models on wolverines in the study area, I followed broadly 4 steps. I first conducted a literature review and selected 4 peer-reviewed research studies that included habitat models for wolverines in the study area. I also grabbed some data from other papers to use as validation. The second step is to process the spatial data. So each paper modeled wolverine habitat based on this environmental data, which I had to replicate in order to extrapolate their model predictions to the area of interest. For example, spring snow cover is important to wolverines. So I processed the snow cover from MODIS satellites into rasters for the study area. For those not familiar, rasters are a type of spatial data where each georectified pixel holds a value, much like a digital photograph. Third, I use the published models from step 1 and their matching habitat covariates from step 2 to predict the habitat suitability across the study area. This then produced 4 model predictions, which I synthesized under a distance-weighted average to create a best evidence habitat suitability map. So I'll dive a bit deeper into these 4 original study areas and original models, which I extrapolated. So you can see these are all recent studies outlined in the different colors on the map on the right, and the study area of interest for this Y2Y project is the dotted lines. So we can see that it provides relatively good coverage and with some overlap between study areas. So all studies found spring snow cover to be positively correlated with preferred habitat. So we know that wolverines seek out these areas for denning, and snow refugia will be important to wolverine population success. 3 of the 4 models found that anthropogenic linear features were negatively correlated with wolverine habitat. This includes industrial cut lines, seismic lines, pipelines, and roads, which provide access for ATVs, snowmobiles, and human-powered recreation to enter otherwise backcountry areas. So when I sum all of these predictions together, it creates a synthesized map of the 4 model predictions, which can be used to identify hotspots in the study area. On the map on the right, yellow represents the best habitat for wolverines, and a dark purple is the least suitable habitat. I then created an interactive visualization tool to share with conservation partners. It's hosted on the cloud and integrated into the Y2Y website. And importantly, this is a user-friendly interface, much like Google Maps, which allows people to view the raster data without GIS software or training. So you don't have to be an expert or have mapping experts on staff. Anyone can just look at this and see where we've identified the best wolverine habitat to be. This is a screenshot of an example of the application in use. Once shared, the user is able to zoom in, scroll around, turn on layers, and change the base maps, for example, to overlay it on a satellite image. And with the satellite image, you can really see that the snowy, rugged mountains provide good habitat for wolverines, which is displayed in yellow, while valley bottoms have been identified as lower quality habitat. The project is not yet complete. We still need to compile recreation data to identify these human hotspots. Other members of the team are using Strava, trail counters, and aerial surveys to map human activities. For example, this is a photo of Annie and Aaron's recent trip to survey backcountry skiing near Golden this spring. There are also many unmapped trails and industrial roads that are being identified with satellite imagery and route logging applications. So for example, there are people who are hiking and mountain biking in areas where the trail is not defined in a parks management plan. And the project's main goal, or final goal of identifying these wildlife and recreation intersections will be the last step, which our postdoc Annie plans to tackle next year. Stay tuned. I'm also working on bringing the Wolverine habitat model synthesis to publication this summer with Annie and Aaron. So when we think of the bigger picture, this project acts as a pilot study, which provides a framework to gather, combine, and extrapolate both wildlife and human land use patterns. So when we know where people and animals go, we can predict areas where conflict might occur. These evidence-based predictions are crucial to identifying and mitigating the effects of recreation on wildlife populations. While I've spoken mainly on Wolverine today, this process can be used across species and across recreation types. As people increasingly put strain on wildlife populations, managing recreation is becoming a key aspect of conservation planning. With many species already under threat from drivers such as climate change and landscape degradation, robust evidence synthesis is necessary to make conservation decisions in high-quality habitat. Thank you.
Thank you, Gabe. It sounds like a very exciting project. So I have a quick question for you. I can see this work that you've done, but how feasible is it to do this kind of work by local governments, or say CRD Parks, or somebody, or a regional park organization that wants to understand what the habitat looks like? How labor intensive is it to create these habitat maps?
It was done, or I did it under the framework of a 6-month conservation science internship. So for one species, Wolverine, it took about 6 months, and I'm still wrapping up some stuff now and preparing it and validating it and making it a bit more robust. But this is sort of a high-level evidence-based synthesis where we're using peer-reviewed models, but there's also other options. For example, in places like in the CRD, there's a lot of public data that could just be run once, such as INAT data, or user submitted data that could be run and created a model in probably a month or two.
Excellent. Sounds doable. Thank you so much, Gabe.
Thank you.
Great. I think we have all 3 presenters now, and we'll have some questions. And I'm going to throw these questions out, and please feel free to discuss them and join in with your comments. So the first question is directed at Cole, but I'm encouraging everybody else to jump in. Cole, so from your research, what would indicate a negative impact on these organisms, wildlife, when it comes to the changes in their activity, and how could that be mitigated?
Yeah, thanks. That's a great question. It is important to remember that in what I presented, we're really looking at these behavioral responses and these correlative associations. So in terms of the actual impact to the wildlife, it's uncertain, because some avoidance by wildlife of people could be a positive adaptation that promotes coexistence if they're avoiding conflict. But some of the costs, some of the negative impacts associated with that avoidance could be things like lost access to resources like food resources. It could be stress, physiological stress. We're doing some work now to try and measure stress hormones in some species in these contexts. And then, it could also influence their interactions with other species. So prey may encounter more risk from predators if they're displaced from habitats that provide cover. So there are a number of potential impacts, and we don't really know all the precise impacts or their consequences for the populations yet. That's more research to be done. But in terms of their mitigations, I think Sarah was right on in that rarely are we mitigating by changing the animal behavior. I mean, in some cases we are, but often the mitigations are focused on human behavior, like number or types of users on the trails and timing of those uses.
Thanks, Cole. Sarah, Gabe, do you want to add anything to that?
Yeah, I'll just add that I think a lot of times the impacts really depend on the species that you're working with and its level of at-riskness. So like working with grizzly bears in Alberta, grizzly bears are listed as threatened under the Alberta Wildlife Act. And we also know that grizzly bears hibernate for 5 months of the year, which only leaves them 7 months to consume 12 months worth of calories. So whenever we're working with bears, grizzly bears or black bears, the impact that we're trying to avoid is that bears somehow eat less or they consume less calories. So we want to make sure that bears have access to high quality habitat so that they can eat as much as possible. We also want to make sure that what they're eating are natural food sources and not garbage or, dirty campground, human provided food sources. And we also want to make sure that that food is available and that they have access to it at times when there aren't people. Because bears are so individual in their response to people, it's really important that if we're managing for the lowest common denominator, then we're managing for a bear that doesn't want to be around people ever. So we always need to, I think, especially when it comes to bears in parks, managing people temporarily throughout the day to increase that human inactive window can be a really great way to make sure that wary bears can still access high quality habitat.
That sounds worthwhile. Anything to add to that, Gabe?
Sure. I'll just talk a bit about what I know about Wolverines, which is sort of a focus of this temporal modeling for Wolverines right now is based on denning, because there's this sort of crucial period of the year to the Wolverine population as a whole, and we know that the Wolverine populations are declining. So they're very slow to reproduce, and they're very solitary. So the female or Wolverine mothers need a lot of space to den, to essentially bolster the population at the moment. And so that is one of the focuses for the whole Wolverine time of year. The denning time of year is certainly a focus.
Thank you. I think there's a lot of good information that comes out of these studies, that's for sure. I think we have time for one more question. And Sarah, you talked about taking into consideration individual animals, especially carnivores, when we're looking at these planning processes. Most of the time we don't hear about that at all. We talk about groups or species. So can you talk a little bit more about that, and how can we take individual animals into consideration when we're planning?
Yeah, I mean, it really depends on how much capacity you have. So there's definitely a growing body of research in the bear world, at least. There's more and more evidence that individuality matters in bear responses to stimuli. And so in a place like Banff National Park, there is a whole team of resource conservation officers. There's actually a human wildlife conflict team of people. And so it's very possible for them to manage individual bears. It's possible for them to say, oh, this bear hanging out around the town of Banff is bear X. And, she just needs to have this habitat for a few days and then she'll take off. Or he just needs to, do this thing and he's fine around people. She's not fine. Whatever. I think it's possible for the park staff to get to know individual bears and manage them accordingly. That's not always possible if you work in an area where you don't have the capacity. And so, so one of the things I think that we can probably get better at as recreationists is in our encounters, just slowing down and taking a second to watch what the bear's response to you is going to be. And so in that way, as a recreationist, you can almost manage individual bears too, because if you encounter a bear and just stop and wait to see what the bear does, that can inform what your reaction needs to be. And I mean, your reaction should probably be to get out of there, but how the bear reacts could inform you how quickly or how urgently you need to figure out a way to do that. So, you know, I think it's a great example of how, like, the science shows bears are individual, but I think managing bears on an individual basis is kind of a luxury that a lot of managing agencies don't have. And so they do the best that they can with the bear population that they have.
Thanks, Sarah. And Cole, you know, when we see your graphs that show, you know, information from groups of animals, is there any way to take individual animals' personalities into consideration in that, in the charts that come out of your work?
Yeah, it's a great question, and it's very difficult to do. So I think you know, we need to do that in these kind of high-profile places like Banff grizzly bears, where we can have the resources to get that information, and then try and use that information to inform our expectations in other areas where we don't have that level of detail. From our work with cameras, it can be quite difficult to identify individuals and track them. So we tend to lump things in that coarser level of just looking at species. It doesn't mean that we can't try to dig deeper, but it would take generally a lot more resources to sort of reach that level of individual understanding of personalities and responses, which I absolutely agree that's very important to consider in these cases. But it's kind of like, you know, in general, we need to make the most of what we have. So if we've learned something in another area, we might try to apply that knowledge in an area where we don't have the same level of detail.
That sounds good. And Gabe, in your work with Wolverines, have you seen any individuals that stand out?
I guess it's always of interest to have this data on an individual level and as compared to a population level. And when we think of Wolverines, they're quite cryptic and long ranging. So to have, like, for example, in studies where they set up a DNA hair snag station at different points on the landscape, you can see, okay, one Wolverine visited 3 or 4 stations, and all these stations are maybe 10 kilometers apart. So you can get a sense of how big the habitat needs and the home range needs of these individuals are. And you can look at that based on their age and sex and maybe role in the population. So it's important to know the individual so you can know what maybe crappy habitat are they moving through and need access to, and then what great habitat are they hanging around in.
That makes sense. So as we are moving into doing some camera studies here in the CRD in the Souk Hills Wilderness Park, I find that what you've just talked about today is so enlightening. I've learned a lot, and I'm hoping to talk to each one of you and get more information. Thank you all for your work, and also for all the time that you've done in this work, and for being here with us. Shauna, can you take the next piece?
Yeah, I'm going to bring us home. So yeah, I just want to echo Nithya's sentiments. These presentations were incredible. I've been live tweeting them, so you're all going to have been have a barrage of updates on your Twitter accounts after this. And I just want to thank everyone at home for sticking with us for a little bit over time, as we have been each time, because the conversation ends up being so rich. So thank you for sticking it out with us. This is our last online session, but we are still hosting an in-person session at University of Victoria on June 23rd. And we invite people to register for that. We'll also live stream it, so folks who are not able to come to University of Victoria can still participate. And that will be a place where we can mobilize some of the things that our expert scientists have shared with us into hopefully better protections for wildlife and habitats in our respective regions. So with that, we will say goodbye to our audience and to our presenters. Thanks everyone again for being here. Bye-bye.
Thank you.
Thanks everyone. Have a great week.
Thank you.